Hello everyone, welcome to the online lab session of 2nd PUC Electronics. In today's session we are going to deal with the realization of gates using NAND gate only. So we are having a IC which is named as IC7400. So here we are going to use this experiment, we are going to use this IC7400 and realize all the gates, basic gates like AND gate, OR gate, NOT gate and XOR gate. Realization is nothing but construction of the basic gates AND, OR and NOT using NAND only. That is, we are going to get the output of AND gate, OR gate, NOT gate and XOR gate using the only one single IC, that is a NAND gate IC, which is named as IC7400. IC7400 is a 14 pin IC which contains 7 pins to the left and 7 pins to the right of the notch. So if I am going to consider this as the notch, I am having 14 pins, 7 to the left of the notch and 7 to the right of the notch. So 1, 2, 3, 4, 5, 6, 7, 7th pin is the ground pin and 14th pin is the VCC. So this is the pin diagram or the pin configuration of IC7400. If you look into this diagram, we will be having 4 NAND gates, 1, 2, 3 and 4. Each gate will be having 2 inputs and 1 output. Let us name these gates as 1, 2, 3 and 4. The very first NAND gate is having a inputs which is connected to pin number 1 and 2, and third pin is the output of the first NAND gate. Similarly, coming to the second NAND gate, 4 and 5 are the input pins, 6 is the output pins. Coming to the third, 9 and 8 are the input pins, 9 and 10 are the input pins and 8 is the output pin. And coming to the fourth gate, 12 and 13 are the input pins and 11 is the output pin. So before connecting these circuits, you have to first connect the ground and VCC. Ground will be connected to pin number 7 and VCC will be connected to pin number 14. So this is the logical diagram or the symbolic representation of a NAND gate where A and B are the 2 inputs and the output Y is equal to A dot B whole bar. And this is the truth table. Here I am having only 2 inputs A and B, so I will be having 4 different combinations 0, 0, 0, 1, 1, 0 and 1, 1. This NAND gate is nothing but an inversion of a AND gate. AND gate truth table is nothing but the output of an AND gate is equal to 1 when all of the inputs are 1. Other the inversion anta helidre, here I will be getting 1s and the last combination will be equal to 0. So this is the truth table of a NAND gate. So how to realize these basic gates using NAND only anta helidre? So this is a circuit what we are going to use in order to construct a NOT gate using NAND only. If you look into these diagrams, we are using only NAND gates and constructing or realizing NOT, AND, OR and XOR. So here this is a NAND gate. We know that NOT gate is having only 1 input and 1 output, but NAND gate is having 2 inputs and 1 output. So what we are going to do is, we are going to short the 2 input terminals of a NAND gate and that will be connected as one of the input terminal, let us name it as A. And the output is only one output which will be named as Y. You have to number these gates looking into the pin configuration. Here I am using only one gate, let me name it as gate number 1. For the gate number 1, 1 and 2 are the inputs, 3 is the output. So pin number 1, pin number 2, 3 is the output. That is, pin number 1 and pin number 2 must be shorted and that must be connected to the input knobs of the trainer kit. To conduct this experiment, we are going to use a IC trainer kit where I will be having a number of input pins and a number of output pins. Pin number 1 and pin number 2 of this IC7400 will be shorted and that will be connected to the input, logical inputs and logical outputs. How we are going to apply the input? By using a push button. We will be having a push buttons. By pressing those push buttons, we will be giving the different combinations of the input. So 0 is the input and 1 is the input. I am having only one input terminal for a NOT gate, so two different combinations. If 0 is the input, the output will be equal to 1. If 1 is the input, the output will be equal to 0. So this is what we are going to check with the help of a trainer kit. If the output is equal to 1, then LED will be turned on. If the output is equal to 0, then LED will be turned off. So you are just going to check with the LED responses of these different circuit diagrams. Coming for this AND gate, here I am having two gates. Let me name it as 1 and 2. The input pins of gate 1 is 1 and 2 and the output pin of gate 1 is 3. So 1, 2, 3. Pin number 1 of NAND gate is IC740 is directly connected to one of the input. Pin number 2 is directly connected to another input. And coming to this second gate, 4 and 5 are the inputs, 6 is the output. Let me write that 6. 4 and 5 are the inputs. What I have to do is, I have to short pin number 4 and 5 of IC7400 and connect it directly to pin number 3. So that the output of first gate is connected as input for the second gate. Pin number 6 will be connected to the output terminals of the digital IC trainer kit. So this is the truth table. According to the truth table, I will be having 4 different combinations. So we will be checking for the output of all these 4 different combinations while conducting the exam. While conducting the experiment. Coming to this third circuit diagram, that is realization of OR gate using NAND only. I will be using 3 different gates. Let me name it as 1, 2 and 3. And gate 1 input terminals are 1 and 2 and the output is 3. Similarly, 4 and 5 are the input terminals of gate 2 and 6 is the output of gate 2. Coming to the third logic gate, third NAND gate, 8 and 9 are the inputs. 9 and 10 are the inputs. 9 and 10 are the inputs. 8 is the output. So how we are going to connect this? 1 and 2 must be shorted and that must be connected as one of the input terminal. 4 and 5 must be shorted and that must be connected as the other input terminal. Pin number 3 must be directly connected to 9. 6 must be directly connected to 10 and the 8th pin will be the output terminal. Coming to this last case, that is XOR gate, I will be using 4 NAND gates. So let me number it as 1, 2, 3 and 4. Pin number 1 is having the input pins of 1, 2 and output pin is 3. Similarly, gate 2 is having the inputs of 4 and 5, 6 is the output. The third NAND gate is having the inputs of 9 and 10. 9 and 10 are the input pins, 8 is the output pin. Coming to the last gate, 12 and 13 are the input pins and 11 is the output pins. So if you are going to number these gates, then it will be easier for us to connect that with the help of a trainer kit. So how we are going to connect this? 1 and 4 will be shorted and that will be given as one of the input terminal. 2 and 10 will be shorted and that is considered as another input. 5 and 9 is shorted and that is connected to pin number 3, that is 3, 5 and 9 are the common points. 6 will be directly connected to 12, 8 will be directly connected to 13 and 11 will be given to the output. And this is the truth table. Since I am having only 2 inputs, there are 4 different combinations. We will be filling the output column after conducting the experiment. So for this experiment, we just need a trainer kit, SAM400 IC and the patch cords, that is 2 mm patch cords. 2 mm patch cords in the sense both the ends are having 2 mm pins. So let us begin with the circuit connections of this experiment and let us find out what will be the output for different combinations of the inputs for all these gates. So this is the IC, NAND gate IC, whose number is equal to 7400. In the very first line, I am having a combination of both alphabets and the numbers. So just neglecting the alphabets, we can read the IC number. So IC number is equal to 7400 and this is the notch of this IC. It is a 14 pin IC. To the left of the notch I will be having 7 pins, and to the right of the notch we will be having the other 7 pins. So while numbering the pins, you have to start from the left of the notch. So it will be having 1, 2, 3, 4, 5, 6 and 7 pins, and you have to come in the U shape after 7 pins to the right of the notch. You have to count it from the down: 8, 9, 10, 11, 12, 13 and 14. So this IC we are going to use in today's experiment, which is having a number of 7400. So this is a digital IC trainer kit where I am having 4 different slots. These are the IC holders. I am just using one IC because one IC contains 4 NAND gates. So what you have to do is you have to place the IC on the IC holder and just lock that using or by pressing this. So the IC is locked. As I have told you, you have to first connect the VCC and ground, only then the IC will work. So here I am having plus 5 volts and the ground connection. Each IC holder will be having ground as well as VCC. So this is the VCC and this is the ground connection. So this itself is a IC slot. We are just going to lock that. So this is IC. You have to just place that in the IC holder, and by pushing this the IC will be locked. But if you have a close look on this IC holder, there is a gap in the last row. But here I am having 1, 2, 3, 4, 5, 6, 7, 8 knobs or 8 terminals to the left of this IC holder and 8 terminals to the right of this holder. But our IC is just having 14 pins, so the last row is left open. So what you have to do is, while connecting the circuit, you have to leave this last row empty. So you have to just consider these 7 and these 7. So the IC, the pin numbers of this IC will be equal to 1, 2, 3, 4, 5, 6, 7. You have to leave this and this. After 7, 8, 9, 10, 11, 12, 13 and 14. So as I have told you, pin number 7 is this. Pin number 7 must be connected to ground, and pin number 14 is this. Pin number 14 must be connected to VCC. Only then our IC will work. So whenever I am going to talk about I am shorting a wire while realizing a NOT gate using NAND, I told you that 1 and 2 will be shorted. So these are the pin number 1 and pin number 2. I have to connect the same wire between 1 and 2 like this. So this is the shorted end. So let's begin with realizing the basic gates using NAND only. So I have already connected the ground and VCC. These are the input switches, logical input switches. Here I am having push buttons. By pushing that switch, 1 is included. By releasing that switch, 0 is included. And these are the logical outputs. That is, these are the LEDs. If the LED is turned on, then the logical output is equal to 1. If LED is turned off, then the logical output is equal to 0. So now let us first construct a NOT gate. According to the diagram, pin number 1 and pin number 2 must be shorted. So I am just using a single wire, and that single wire will be connected to pin number 1 and 2. That is what is called as shorting. From that shorting end, I am just using another wire, and from that shorting end, I can either connect to pin number 1 or pin number 2. From that shorting end, I am using another wire and giving that to input switches. So these are the input switches. I can use any of these switches, and pin number 3 is nothing but the output pin. So pin number 3 is connected to logical outputs. These are the logical inputs, red color ones, and these green color ones are the logical outputs. So this is the connection to realize a NOT gate. Now let us check how this is going to work. Let us first turn on the trainer kit. Now I have not applied the input, but the output is already been turned on, LED is turned on. So for the logical input which is having a value of 0, the output is equal to 1. As I have told you, if LED is turned on, the output is equal to 1. If LED is turned off, the output is equal to 0. For the 0 input, output is equal to 1. Now let me check by applying the input. Whenever you are going to apply the input, the LED which is present in front of the push button will be turned on. So the input value is equal to 1, but now LED has turned off, so the output is equal to 0. So we have successfully constructed a NOT gate using NAND only, where for the input 0, output is equal to 1, input is 0, the output is equal to 1. For the input 1, the output is equal to 0. Now let us connect with the second circuit diagram. Let me retain that ground and VCC as it is. So now let us realize a AND gate using NAND only. According to the diagram, pin number 1 must be connected to A. What is A? A is nothing but the input. So I am connecting that to one of the switches. Similarly, pin number 2 is B. B is another input. So I am directly connecting that to another input terminal. Pin number 3 is connected to 4 and 5 short. Here I am using a single wire to short 4 and 5. I have shorted this 4 and 5. For that shorted end, I am connecting a separate wire, and that will be connected to pin number 3. So the first gate connection is over, and the first output, that is pin number 3, is connected to the shorted ends of 4 and 5. Pin number 6 is connected to output. So in this I am having 2 inputs and only 1 output. Now let us turn on the trainer kit. Here for the input combination 0 0, here the inputs are 0 0, the LED is also turned off, the LED is turned off. Now let me check for the second combination. A is 0, B is 1. I have turned on B, LED is still in the off condition, and let me check for the third condition. A is 1, B is equal to 0, LED is still in the off condition, that is LED, that is logical output is equal to 0. When both A and B are equal to 1, the LED is turned on, telling that the logical output for the last combination, that is when both A and B are equal to 1, the output is equal to 1. Clear? The experiments are very simple. The only thing is you have to write the pin numbers correctly. Now let me check how to construct a OR gate using NAND only. Let me retain this ground and VCC pin as it is and construct or realize a OR gate. According to the diagram, pin number 1 and pin number 2 are shorted. Let me use a single wire and short that pin number 1 and pin number 2. From that shorted end, we have to connect that to input pin, that is logical input pins. So this is considered as A, and pin number 3 will be connected to 9. So this is 8. I am just leaving the last pin. This is 8, this is 9. Pin number 3 is connected to 9 directly. Pin number 4 and 5 is shorted. Pin number 4 and pin number 5 is shorted. From that shorted end, I will be giving that to another input switch, which will be considered as B. So from that shorted end, I will be giving it to another switch, which will be considered as B. So this is A and this is B. And pin number 6 is directly connected to 10. So this is 8, 9 and this is 10. Pin number 6 is directly connected to 10 and pin number 8 is connected to output. So this is the connection to realize a OR gate using NAND only. Let us first switch on the power supply, switch on the trainer kit. So now let us check with the different combinations. When both A and B are equal to 0, the LED is not glowing. It implies that the output is equal to 0. Now for the second combination, A is equal to 0, B is equal to 1, I will be pushing this switch, that is 0 and 1, the LED is turned on, indicating that the output is equal to 1. Now for the third combination, A is 1, B is 0, LED is again turned on, and it implies that the output is equal to 1. And for the last combination, when both A and B values are equal to 1, I am just pushing these buttons, A is equal to 1, B is equal to 1, and the LED is turned on, indicating that the output is equal to 1. So we have successfully realized OR gate using NAND only. Now we are left with the last gate, that is the XOR gate, where I will be using all the 4 gates of a NAND gate. I am retaining this ground and VCC. So let us begin with the connection. Pin number 1 is connected to pin number 4. This is 1, 2, 3 and 4. And from that shorted end, I will be connecting a wire to the input switches. So this is A. Similarly, pin number 2 is shorted to pin number 10. This is pin number 2. This is 7, 8, 9 and 10. From that shorted end, a wire will go to the input switches, which will be considered as B. So this is B. This is A and this is B. According to the diagram, pin number 5 and pin number 9 are shorted. This is pin number 5, 8, 9, pin number 9. Pin number 5 and pin number 9 are shorted. From that shorted wires, a connection will go to pin number 3. So the connection, when you look into these wires, it looks clumsy, but it is easier when you connect that in the trainer kit, looking into the numbers. So I am done with 5 and 9 and 3. The next is pin number 6 will be connected to 12. This is 8, 9, 10, 11 and 12. Pin number 6 is directly connected to 12 and pin number 8 is connected to 13. So this is 13. Lastly, I am left with only one connection where pin number 11 will go to the logical output. So this is Y, this is A and this is B. So I am done with the connection. Now let us check with the different input combination by turning on the trainer kit. So now the inputs are 0, the LED is not turned on, implying that the output is equal to 0. Now let us move on to the second combination where A is equal to 0, B is equal to 1. The LED is turned on, indicating that the output is equal to 1. Coming for the third combination where A is equal to 1, B is equal to 0. The LED is turned on, indicating there is output of 1. And for the last combination, when both A and B are equal to 1, LED is turned off, indicating the output is equal to 0. So we have successfully constructed an XOR gate using NAND only. Now let us turn off this trainer kit and remove the connections. The experiment was conducted with the help of a trainer kit using a single IC 7400. So the tabular columns, the truth tables are filled. Wherever I have written as 0, there the LED was turned off, and wherever I have written 1, the LED had turned on. We have already seen that while conducting the experiment. So using this NAND gate, using that only single IC 7400, which is an IC of a NAND gate, we successfully constructed, or we successfully realized NOT gate, AND gate, OR gate and XOR gate. So the result is these gates are constructed using 7400 and their respective truth tables are verified successfully. I hope you have very well understood this experiment. In my next session, I will be coming with a new experiment. Until then, take care. Bye-bye.